All right, these are your 9-3 notes. This is like the transformation of quadratics. So first thing I'm going to do is I'm going to explain what all the numbers will do in these equations. If it moves it up, if it moves it down, if it flips it upside down, if it goes to the left, goes to the right, if it becomes stretched, if it becomes widened. You have the other worksheet that has all the vocabulary on there, but I'm going to explain those numbers and then we're just going to plot it using our calculator. So first thing that you need to know is you need to know what these numbers do. So first thing here, let me start with number 1, and we're not doing all these, okay? So first starting here with number 1, you have this negative. First thing I want you to write down, wrong color, is that negative, okay? So that negative, all this does is it turns the graph upside down. All right, the next thing that we're going to look at is this plus 3 right here. Okay, whoops, did not want to do that. Plus 3, the plus 3, all that does is it moves left 3 units. Okay, and then you have this minus 3 back here. And that minus 3, it shifts the graph down 3 units. All right, and so I'm just going to go ahead and plug this into my calculator. So I have negative parentheses x plus 3, all of that is squared, minus 3. I'm going to look at my table to find my points to plot. And the first point that I can plot is negative 5, negative 7. So I'm going to go ahead and plot negative 5, negative 7. Then we have negative 4, negative 4. Then we have negative 3, negative 3. Then we have negative 2, negative 4. Then I have negative 1, negative 7. And the next one is negative 12, and that's off the chart. Okay, so here is my graph. So when I say all this stuff that's happening to it, okay, I'm comparing this to the parent function. Your parent function is y is equal to x squared, and I'll just draw a little sketch up here. Y equals x squared. On your graph, it starts here at the origin, okay, and it looks like this. All right, so if you notice, that negative turned it upside down. Then we went 3 units to the left, and then we went 3 units down. So that's how we ended up in this quadrant. Okay. Here we go, number 2. So let's decide what happens here, number 2. First thing that I'm going to highlight is this negative 3. Okay, that negative 3, what that does is not only does it turn the graph upside down, so it turns upside down, but that 3 also, it stretches it. So it's stretched. Okay. The next thing I'm going to look at is this negative 2. So this negative 2, okay, what that does is it moves 2 units to the right. And then we have, let's see, this minus 1 back here. Okay, and the minus 1, all that does is it shifts the graph down 1 unit. Alright, so in my y equals, I'm going to type this equation in negative 3x minus 2 squared minus 1. So I get my table. I can't plot any of those. Let's see, I can plot 0, negative 13. So 0, negative 13, 1 and negative 4, 2, negative 1, 3, negative 4, and then I have 4, negative 13. Okay, so a really good thing to do is if you go back into y equals and y2, if you type in x squared, so y2, I'm going to type in x squared. If you look at your graph, you can compare the two graphs just to make sure you are correct. So what we did here is we turned the graph upside down and it was stretched, which you can tell because it looks like it looks a little bit more kind of like skinny. We went 2 units to the right and then we went 1 unit down. So that's a really good way to compare the two is using your calculator. All right, number 3, we have a couple things that we have to identify first. So first I have this negative. So what I know about the negative is that it's going to turn the graph upside down. Another way you will see that is it'll say that it was flipped across the x-axis. So I'm going to write that down. So you can have that. It's the same thing as being flipped across x-axis. Okay, so the next thing that we have here is this -1. So the -1, that is going to move everything right 1 unit. And then I have this -1 in the back. The -1 in the back is going to move everything down 1 unit. So I'm going to go ahead and put this into y equals. So I have negative parentheses x minus 1 squared minus 1. Look at my table to see what I can plot. Cannot plot that. I can plot -1, -5. I can plot 0, -2. I can plot 1, -1. And I can plot 2, -2, and 3, -5. Connect my dots. Okay. Right. And so you can see how this graph was turned upside down. We moved 1 unit to the right, and we moved 1 unit down. So if you look at your graph and compare it to y equals x squared, you can see all of these transformations. All right, let's see. We're going to do number 4. So number 4, we have y equals x plus 1 squared minus 1. I'm going to look at my table. So I can plot, let's see, I can go ahead and plot the first one. Actually, before I plot it, let me write down a couple important things that you need to know. One thing you need to know is this plus 1. When I compare this to the parent function, that plus 1 is going to move this whole graph left. So it moves left 1 unit. Okay, and the minus 1 back here that we have, that -1 is going to move everything down 1 unit. So when I plot my points, I have -3, +3. I have -2, 0. We have -1, -1. I have 0, 0, 1, 3. And the next one's 2, 8, which is off the graph. So here is my parabola. All right, so when you compare this to y equals x squared, the parent function, you can see that all we did is we moved every point over left and down 1. So left 1 and down 1, and that's it. Okay, I think we're going to do 4 more, and then we will be done. So number 5, a couple of things that we need to identify first. First, you have this -2 out in front. So that -2, it's going to flip it across the x-axis. So flip, put x-axis. And that 2 is going to make it stretch. So this stretches. All right, next thing that you see is this +4. Okay, when it's inside the parentheses, it goes either left or right. So the +4 is going to move left 4 units. And anything that's outside the parentheses in the back, okay, that moves it up or down, or shifts. You'll see the word shifts up and down. So this -2 shifts everything down 2 units. All right, so let's go ahead and plot what I can. I'm going to put in y equals. So I have -2 parentheses x plus 4 squared minus 2. In my table, the first point I can plot is -3, -10. So -3, -10, -2, -4, -1, -2, 0, -4, 1, -10. Okay, so when I connect my points, and we compare this to the parent function, y equals x squared, you can tell that we flipped it across the x-axis. It did stretch. We're moving 4 units to the left, and we were moving we moved everything down 2 units. And I plotted that wrong, so I typed in +1 and not +4. So hopefully y'all caught on to that before plotting your points. Because I typed in 1, not 4, that's why I was trying to figure out how can we shift over to the left 4. Here we go. Now we have some points we can graph. I can graph -6 and -10. negative 5, negative 4, negative 4, negative 2, negative 3, negative 4, and negative 2, negative 10. So this is why it's a really good thing to put this in your calculator and compare it to y equals x squared and just go over what you have, because now I see that, hey, when I was here at the origin, okay, at 0, 0, I moved over 4 units and 2 units down. All right, so that makes a lot more sense. Okay, here we go. Number 6. Okay, there's nothing in front as far as like a negative or a number that's going to change it. What we have next, though, is this plus 2, so that's either going to move it left or right. Since it's a plus 2, we're going to go left 2 units. Okay, and the back side is plus 1. Whoops, did not mean to do that. It's plus 1. Okay, if it's in the back side, you can move it up or down. Since it's positive, it moves up 1 unit. Okay, so let's go put this in so we can graph it. We have x plus 2 squared plus 1. When I look at my table, I can start at negative 5. So negative 5, 10 I can't plot. Negative 4, 5 I can. So I have negative 4, positive 5. I have negative 3, positive 2. I have negative 2, positive 1. Negative 1, positive 2. Then we have 0, 5, and 1, 10 is not on my graph. So here is my quadratic, my parabola, and you can tell from your parent function that this went 2 units to the left and 1 unit up. Okay, let's see, let's just do one more. The last one I want to do is number 12. Okay, I'm sorry, not 12, 14. 14 is the last one I want to do. So let's look at this one. So first you have this 1/2. Now, that's the wrong thing again. You have 1/2. This 1/2, it doesn't stretch. The 1/2 actually widens the graph. Okay, then you have this in minus 4. So remember, it either moves left or right. Well, when you have the minus 4, that's going to move right 4 units. And then whatever is in the very back, okay, it's either going to move it up or down. Since it's a minus 2, it's going to shift down 2 units. So I'm going to put this in y equals to graph it. So we have 1/2 parentheses x minus 4 squared minus 2. And when I look at my table to plot this, let me see what number I can start with. So I have 0, 6, I can't plot. I have 1, 2.5, I can plot that. So 1, 2.5, I can plot. 2, 0, I can plot. 3, negative 1.5, I can plot. 4, negative 2, I can plot. 5, negative 1.5, I can plot. 6, 0, I can plot. 7, 2.5, I can plot. And that's all the x values that I can plot. So when I graph this, you can definitely tell that my graph has been widened compared to just to y equals x squared. We went 4 units to the right, and we also went down 2 units compared to your parent function, which is y is equal to x squared. All right, so you have all these extra problems on here that you can try for yourself. If you need to come after school one day just to work these out, you're more than welcome to. So if you need any help on this stuff, just let me know.